I'll do that one too. Anything else?
This one. And this one.
I shall do them in the tutorial then. Okay.
Yes. Yes. Yes.
Oh my goodness.
Did you have the...
مقطعة.
Yeah.
فانكسين مقطعة.
Huh?
مقطعة.
What does that mean?
It means sharp now.
We don't
Only in Arabic.
Yeah.
Let's continue.
Sharpener يا حلو.
Oh,
Hey. Chub. Chub. Chub Gabi.
Chub, yeah.
Oh, thank you. Correct my grammar, thank you. Tamam. Now, we'll continue. Yusuf. Omar. We'll continue now. Alright. Go on. Are you ready? No? Come on. Can you turn the light off, please, while you're there?
Primary school.
It is a bit, isn't it? Thank you. Okay, so we're starting a new chapter. We'll come back to calculus later in the semester, but we're moving on to a new chapter. We're looking at domain and range. No.
Not range.
Not the statistics range, no. Functions range. Yes? What's wrong with you? Oh my goodness. So dirty. Now, F is a mapping from a domain to a codomain. So the way we think about F, it takes something in what's called the domain and then gives you something in what we call a codomain. So an example would be if I had f of x equal to x squared. F, we say, takes a real number and gives me a real number. This is an example. So if you put in the number 3, you get back the number 9. So we call F a mapping. It takes a number from one space and gives you a number from another space. It doesn't have to be a number. That's just what we deal with, but that's what a mapping is. You get the idea? Yep. So we have domain and we have codomain. But for the first lesson, we're only really interested in domain and codomain being real numbers, because that's what we're dealing with in maths. So what precisely is the domain? Well, the domain isn't always the real numbers, because for example, if I had a function like this, does it take a number from the reals? No, it doesn't, because you can't use negative numbers. So this function only takes not integers, positive numbers. It only takes positive numbers, and it gives me a real number back. But does it give me every real number?
No.
No, it only gives me what real numbers? What types? Oh, stop,
Positive.
stop saying integers, there's nothing to do with integers in this.
Uh,
Positive numbers.
yeah.
Yeah, so we need a concept for what we get back from the function. So this is our first definition. Firstly, let's deal with domain. Domain of f equals the allowed values of x. For example, the domain of fx equals root x is the positives. Make sense? And the second definition is the range of f. And that is the values of y returned, meaning the values you get back from the function when you put in a number. So an example, the range of, let's say, fx equals, we'll go with square root x again, is, this function only gives you positive numbers, so 0 to infinity. Yeah. What does this represent on the graph though? So that's what we'll do next. So just to get started, you'll definitely want these examples and definitions written down
We're only doing 1-to-1?
for the moment. Let me actually have a look at the lesson. We're not even doing 1-to-1 today, we're just doing onto. Definition. If the range is equal to all real numbers, we say it is onto. So if I describe a function as onto, it means I'm saying its range is all the real numbers. You look so worried, Lee. Too much English? Yes. I'll draw some pictures now, okay? But write this down.
What's the closest bowling place?
The closest what?
Bowling.
Tala.
Entertainment blocks?
There's some.
The square?
It's not. I don't think it's in the square, but there's some place near the square. Some place in Tala. There's a bowling alley. It's part of.
Entertainment block.
Yeah, it's a Leisureplex, I think it's called.
Leisureplex,
Yeah.
And how much is it, would you say?
It's reasonably priced. We have a group of 4 people playing for an hour. Maybe it'll cost like €5 each or something. It's, not that expensive. You might have to book it at least a day in advance. It depends what day you're going. So obviously if you go on like a Friday evening or a Saturday, they might not have any empty lanes. But if you're going in the middle of the week, then you wouldn't have to book it, I don't think. But might be safer to book it online.
An adventure.
Yes. Adventure in the bowling alley. Yes. Okay. Can I scroll down? Yeah. Can I scroll down? Yes. Let me draw this on a graph. Okay. So let's say this is our function here. X and Y and F. What we call the range, that is the values of Y. So on the graph, the range is all the values of Y I can get. So it's from this number up to infinity. This is not included because the graph doesn't go down here. So for example, if this was -1, I would say the range equals -1 to infinity. The domain are all the values of x. Here, I can use all the values of x. Nothing is forbidden. So here, the domain, that's equal to all the values for x. Is this function onto? It is not. Because I said onto is when the range equals the real numbers, and this does not equal all the real numbers because we are missing quite a lot.
But the domain,
The domain is all the real numbers, but the range is not. And onto means the range includes all real numbers.
So x is always, like domain is always infinite, minus infinity.
No, it's not. Let's have a look at an example when it's not.
will we be asked what type this function is, if it's an onto or?
Yes, that's why I'm teaching it to you. So here, Yahya is an example of when the domain is not this. So for example, if you have something like 1 over x, the domain for 1 over x is equal to all the real numbers except 0. Why not 0? Why can't we use 0? Well, because we can't divide by 0. So in this function, we can use all real numbers except 0. And what is the range here? That's the domain. What's the range? Yeah.
Minus infinity or
Except 0. Because
oh, okay.
it skips over 0. So is this onto?
No.
No. No. So we'll have a look at some more difficult examples, but this is the basic concept. And we'll have a look at some examples now. So the way you do these questions, some of them you might want to draw a graph, some of them you might want to use calculus. For example, if I have a function like this and I want the range, then if I found the minimum point, I could find the range, because the range would be all these values of y. So you actually have a few ways you can think about and do these questions. So let's have a look at some examples. Can I go to the worksheet for a second? Yes, go on. Let's have a look. Let's do the first question together. We'll write the answers down together. So, question 1A. We'll start with 1A. These questions don't need anything special. We can just write the answer down. No, we can write the question down if we want, but I was just thinking we could write the answer down. So in 1A, what is the domain? What are the allowed values of x?
All real numbers.
All real numbers. So, first one is all real numbers. Good. B,
All real numbers.
all real numbers. Lee, please write this down as I'm speaking. B is all real numbers. C,
How do you
All
know?
real numbers.
how do I know? Because if you look at it, there's no value of x that's not allowed.
Oh, so like you just substitute in a value.
No, you just look at it and ask yourself,
No.
is there any value of x I can't use?
So 1 over x is 1.
That's, yeah, we'll get to that one in a sec, yeah. So C is all real numbers, again. However, D
It's not.
is not all real numbers. It's all real numbers except,
Two.
not 0, look at it, look at it.
Two.
2. We can't use 2, why not? Because it would make 0 in the bottom. You understand this? Okay. Now E is starting to get a bit more difficult.
Is it fine if it makes 0 on the top?
Yeah, yeah. E, we need to figure out what the roots are, right? So I'll just use the calculator here. What have we got? 1, minus 39, and 374. So for number E, it's all real numbers except 22 and 17. For E, if you can write that down. All real numbers except 22 and 17. You got that? Yeah. Okay. F, all real numbers. G, now let's do G together. Now it's getting interesting. G, what is it? Log x squared minus 11x plus 18. Yeah? So what is the problem for log? When could you have a problem with log?
If it's 0.
That is one problem, and negative. Negative. So for the domain, we require,
Positive.
yeah, and also not 0.
Yeah.
Now, I do wonder, does this quadratic 9 and 2, so we need this to be true. So we need above or below?
Above.
So we need x to be less than 2 or greater than 9. So this is the domain. So if you want to write it out as sets, it's from minus infinity to 2 or 9 to infinity. In other words, for this function, we cannot use the values between 2 and 9. We need to use outside of this so that the quadratic can be positive, so that the log is defined. Okay, this is now more like what you get in the exam, so please write this one down.
The question would be find the domain.
Yeah. Or they probably use something like state a suitable domain or something like this.
Domain is a symbol up.
Say again?
Domain is a symbol up.
Domain? What about it? Goes up? I'm sorry, I can't hear you because I'm tired. Please say it again. No, I'm just tired and sleepy because I'm busy and I can't hear you.
He's asking domain, is domain y-axis or x-axis?
No, domain is x-axis.
So one can tell me. Please repeat yourself, Juan. I'm sorry, I'm very tired. What did you say? No, please. What did you say? I'm just so tired I couldn't hear you.
How about the echoing sound? My awesomeness.
Yes, I couldn't hear you with bicycles. What was your question? Alright, fine. Fine. If you want to ask me later, you can. Alright. Can we continue? Yes? Alright. Before I go on to the next part, which is finding the range, I just want you to try one by yourself. So can you try this one here, K? I'll zoom in. This one here. I want the domain here, please. Just write it down. Don't say anything, just write it down. Sorry, I should be more precise with my English. Don't make any noises, just quietly write it down. Got the answer, Lee? Andrew? Okay, what's the answer, Yusuf?
All real numbers except 4 and
Yes, except for 4 and 1. Wait,
No.
How is it?
no, one of those should be a minus, right? The roots of this, it's x. No, sorry, you're right, sorry, 4 and 1. Everything except 4 and 1, because 4 and 1 would make the denominator 0. Yeah.
So then, how do we know if it's from like minus infinity to
Yeah, it's not like that one here. What did you say the answer was? All real numbers except 1 and 4. Yeah.
So what we have to do is make the denominator 0.
Mhm. Continue now. Now, I want to show you how to calculate the range. There's a couple of ways to calculate it, but some of these are very hard. But some of them are very easy. So again, some we can do in our head. The range is the values on the y-axis you could have. So if the graph is always increasing on the right and decreasing on the left, then the range is all the real numbers. So let's do some of them together in our head. A, all real numbers, is a straight line. B, not all real numbers. So what we need to do for B, figure out where this is, and then it's everything above that. So we need the minimum here. How do we get a minimum? Derivative equals 0. What's the derivative here? 4x minus 4. Yes? How could you say question and then not have the question ready?
I forgot the name of the thingy. When it's a bracket and square plus.
Complete the square can also be used, yes. But I'm doing it the quickest way because I'm tired.
Isn't that
You're using up my very little energy I have left this week.
That one is quicker though.
OMG. I can differentiate this in my head. I cannot complete the square of this in my head because of the 2.
So you're tired.
Yeah, I'm so tired, and I have this one student here that is trying to kill me. What is the derivative here? 4x minus 4 equals 0. So what does x equal?
1.
So if I put 1 back into this, I get y is 2 minus 4 minus 2 is minus 4. So I know it doesn't look like it because of how I drew it, but this here is minus 4. So what's the range? All the numbers above 4, minus 4. Get the idea? Noisy student? Get the idea?
But I still don't like that we have different brackets for ourselves.
The brackets matter.
That's why
Yeah, can we write them in as inequalities?
Yes. If this makes you happy. What was your question, Fawn?
I want to go.
Continuing. So,
You will miss me.
yeah, like a headache. Right, C. What is the range here for C?
Same thing as the first one. The same thing.
No.
The second one.
The second derivative?
All.
All real numbers, because cubics look like this.
Up and down.
So you get everything. So, all real numbers.
No fake ones.
Yeah, no poser numbers. Just legit numbers.
Yeah.
Yeah. They see me rolling, they hating. Right,
Can I see the?
my beautiful picture.
Suits my outfit for today.
It does, yes, yes. For some reason the song, this particular song comes to mind, although it's not so relevant for you, you know, Pretty Fly for a White Guy. We'll have to change it slightly for you.
Not that way.
No, exactly. But you are pretty fly.
Good. I can catch more honey being black.
I know you can. Yes.
You don't see races.
I'm still in my car, so I thought, from races.
There was a video of a woman complaining on how she doesn't see races and genders and all. All people are saying, I don't see races, I don't see genders. Still have business with that.
Yeah. Now I'm just thinking the next thing I want to show you is quite difficult. So before going on, are we okay with the idea of range here? Yeah. Now, this way I'm doing it, of using the graph, that's okay for something simple like a quadratic, a linear, or a cubic. But for problems like D, E, F, and especially K, doing it by a graph is way too difficult. So we need some other method for calculating what the range is. And this is what I'm going to show you. And I'll use D as an example because it's not so difficult. Okay? So how do we find the range? And the method I'm going to show you works for all the questions. So the way we did the previous ones, you could use this method as well. So the method is done in a couple of steps. So first step is you let y equal your function. Okay? The second step is you make an equation usually equal to 0, fx minus y equal to 0. And then the third step is the key step to getting the answer, is you find the values of y so that the equation in number 2 is solvable. So what does that mean? The best way is with an example, but these are the 3 steps. Okay, so let y equal to your function, make it equal to 0. When is it solvable? Let's have a look at with a simple example. Okay, what was the one I was offering to do? 1 over 12x plus 12. So we have fx equals 1 over 12x plus 12.
Isn't this just one? Oh,
I know,
negative.
I'm doing a simple one on purpose to show you this method. I feel like you don't listen to me. You just listen to what you want to hear, which is not me.
No.
Yes. Is it not?
No.
Can I continue? Can I show you this simple one to demonstrate the method? Great. So, what is step 1? You make y equal to the function. So step 1, you make y equal to 1 over 12x plus 12. Step 2, you try to make it equal to 0. So I think I should divide or multiply across. So I get y times 12x plus 12 equals 1. And then what should I do next? Well, move the 1 over and also multiply this out. So I have 12yx plus 12y minus 1, equals 0. Or to be more clear, I have 12y brackets x plus 12y minus 1 equals 0. Finally, step 3. When is this equation solvable? Well, if you think about it, this equation is of the form mx plus c, where we, although I didn't say it here, we think of y as a constant in the equation, not as a variable. We imagine it as a number. So, when you have a straight line and you want to solve it when it equals 0, when it crosses the x-axis, in other words, the root, you can always solve a linear except in one situation. What is the situation when this is not solvable? When m is 0, because then it's a parallel line that doesn't actually cross the x-axis. So you can always solve if m is not 0. Because if m was 0, can we find x here? No, that's ridiculous, because there isn't an x. Ridiculous. Totally ridiculous. So, here, what is the m? 12y. So this is solvable as long as 12y is not 0, which means y is not 0. So this is the answer. The range is all the real numbers except 0. So you do get every value of y except for 0. And if you look back at the question, that kind of makes sense. It's impossible for this fraction to be 0 because you only get 0 when the top is 0. And could the top be 0? No, never. It is a new method, I'm sure,
Could you
for most of
repeat
you.
the last part about the top being 0? We only get.
No, ask Faisal, please.
Can you get a range that is equal to 0?
What would happen if the top is 0?
If the top is 0, then the answer is 0, then the range is 0. But the top is not 0, and it won't ever be 0. So you can
Because why won't it ever be 0?
This one.
Yes. And 1 is not 0. That's what you learn in Trinity now.
Oh.
Advanced maths like that.
Oh, so what's with the money?
Oh, yeah. Oh, don't worry, the government pays for it, so.
Oh, that's why.
180. Mhm. Okay. Can we do another example using this method? Just for more practice, yes?
This method we find the range, not the domain.
Correct. This only gives you the range. Alright, let's try another one. Let's see. We'll do the E example. Y equals E 13x minus 7. Well, not y, that's the function. We'll call it fx or whatever. Okay, what's step 1 finding the range here? Y equals E 13x minus 7. Step 2?
Make it solvable.
Make it equal to 0. Make it an equation. I feel like I want to have a log in here to simplify it a bit. So I get log y, log e, they cancel. Log y equals 13x minus 7. So I have 13x plus minus 7 minus log y equals to 0. When is this solvable? Well,
When y is...
yeah, this equation is always solvable because the slope is not 0, it's 13. So you have something that looks like this. It will always cross the x-axis. However, when you examine the c part closely, you discover, oh, well, okay, I need an m, but I also need the c. In the previous example,
The c can be 0 though, it's fine.
I know, yeah, and here the c could be 0. That's fine, yeah, you're absolutely right. The c could be 0 here. But the c has to exist. And this c only exists as long as y is positive. This c does not exist if y was a negative. So it looks like this is valid or solvable as long as y is a positive, because you can solve this as x equals 7 plus log y over 13. But of course this needs to be valid. So it looks like the answer is all the positive numbers except 0. Yeah. Continue. So before we finish, I want to give you one to try using this method. Can I scroll down? Not yet.
The lecture is for an hour or
This lecture
two.
is 2. If it was 1 hour, it would be way late.
Not this one, not this one.
The next one.
They are getting representative from
Oh, that thing. Yeah.
what thing?
Nothing. The climate change thing.
Oh.
I know things. Right, can you all try J, please, for me?
Was it a coincidence you chose that letter?
Huh?
Was it a coincidence you chose that letter?
No. Get an answer? What you got, Yusuf?
I think I overcomplicated.
Any real number.
Correct. So you make y equal to log 9x plus 18. So EY is equal to 9x plus 18. So 9x plus 18 minus EY equals 0. Is this solvable? Well, the slope is never 0 because it's 9, so that's good. And in fact, any value of y here is acceptable because this is always defined. So there's no value of y we can't use that would not make this solvable. So the y is good. It's all real numbers is the answer here.
Yeah, but why did you use the 8? There she could have just minus logs from both sides, so it becomes y minus log.
Minus log from both sides?
Yeah,
Yeah, to make y minus log equals 0.
yeah. Not to say that, and then y was like, it can be any number.
Yeah,
How
that's
do you
okay.
minus log-
I prefer my way though.
Yeah.
How do you
just
minus
these
logs
steps.
from both sides?
Minus log 9x plus 18 minus log 9x plus 18.
Oh, okay. Move log to the other side, basically.
Essentially.
It only took me like 3 steps. This took more.
But I like this one.
And you don't have to derive or anything.
Not this one. Okay, just so you know, it's good if you can do it. K is the ones, basically the ones with the quadratics in it like E, well not E actually, well no, yeah E, G, H, K, the ones with the quadratics in it. I actually didn't do any ones with the quadratics. I want to see if you can figure it out yourself. They are a little bit tricky, and if you have trouble with them, of course we can do one in the tutorial next week, just pick one out. But just so you know, make sure you get a quadratic one attempted, because they are hard, and you know, they could be on the exam. K, if you're wondering what the hardest one is there, K is the hardest one. Most difficult. Okay? Okay, we'll finish.